Chapter 1, Section 3, sorry about that, is all about the atom and where it came from, how we came up with the term atom, etc. So the first thing is atomos or atomos, however you say it in Greek, means uncuttable, meaning it's the smallest thing that can be created. Democritus, who was a Greek philosopher, came up with this idea. So when he called something atomos, today's scientists took the word atom from that term to mean the smallest particle of anything. Okay, so atoms can't be broken into smaller pieces. Dalton was a teacher over in England, and back in the 1600s when he was a teacher, he would meet with his fellow teachers and philosophers and come up with ideas and what things meant. When he tried to explain what an atom was to people, he said they were like tiny marbles. They were solid throughout. He was pretty close in his ideas, but he wasn't 100% accurate. We know this now 400 plus years later, but back in the 1600s, that was pretty much their best guess. We know that all atoms are alike in any element. So all of the atoms of hydrogen are going to have one proton, one electron, possibly a neutron, depending on if it's an isotope. Atoms of different elements are different. So the number of, if I have carbon, it's going to have 6 protons versus the 1 proton for hydrogen. Atoms of each element have a unique mass. There's nothing about it that's going to change. So the mass of the element in a compound are always in a constant ratio. A chemical bond is the force that holds 2 atoms together. A molecule is when we have 2 or more atoms bonded together. We call anything a molecule if it's in organic form, meaning it's got carbon as part of it. All right, the Section 3 questions. If you break an element into its smallest particles, what do you have? You have an atom. Dalton visualized atoms to be like marbles, and no, we cannot break ice into anything smaller than just that. The smallest particle of any molecule of water is going to be water. And finally, the last 2 questions. In the example they gave you, the elements represented for acetic acid. The first one was carbon, that's black, hydrogen was blue, and oxygen was red. The ratio of copper to oxygen in the example is 4 to 1. So if I have a 40-gram sample, that means there's going to be 10 grams of oxygen.